Thanks for the organizers for having me here. Looks like it's thinned out a little bit. I guess the prospect of talking about weather scared people away. But one of the things I'll talk about today is really kind of the framework that the weather company has developed for both data science and what we're doing as far as framing, this IoT discussion. It's interesting because most people that have been in data science for a while, you kind of come in it from a particular domain. So I came into data science through physics, and I've always been working with weather, atmospheric data, space data, and doing this for a while, since before even the term data science was coined. I think there's a good and bad thing that we can associate with the term data science. So it's kind of one of those terms that, and we'll talk about this as it relates to IoT also, it means everything and nothing all at the same time. So, and some of the earlier talks kind of hit upon this. When you say you're a data scientist today, it doesn't really mean a whole lot until you kind of dig in and see what skill sets, what domains do you come from, what does that actually bring to the table, because it's kind of a term, I use biological metaphors a lot, and if you kind of say the term biologist, biologist could be anybody from a molecular biologist who's doing genome sequencing to a field biologist who's outside counting butterflies. And both of those people are still going to be calling themselves biologists, but other than a few core skill sets, they're very different scientists. And data science is kind of the same thing. So, the term data science is good because it's raised visibility. So we can go anywhere now and say we're data scientists, and people think that we're doing something special. We can, really kind of garner the attention in kind of technology and mathematics circles that it seems like most people in this field are generating right now. But the flip side is there's a lot of ambiguity around that, and even when it comes to trying to staff a team of data scientists, and it might have been the earlier talk that mentioned it, there's really no such thing as a perfect data scientist. And if somebody comes in and says, I can do everything, those are usually the quickest people to weed out, because the skill sets that are required, the technology is changing so rapidly that it's nearly impossible to be this one-size-fits-all. And as we're approaching how to structure data science in the context of what weather company and IBM is doing as a precursor to what IoT is going to be, we're going to take some of the same learnings that we have here, and I think we can apply some of the same principles that we're doing in terms of this dialogue around data science and what it means. I think the same thing will be prevalent to what we're talking about with respect to IoT in the future. So I'm just going to spend some time talking about what we're doing here. And when I say weather and IBM, I use them interchangeably. So a few months ago, the weather company was purchased by IBM, so it is an IBM business. And when you're working in weather, weather is really kind of, in my view, it's kind of the ultimate big data problem. What data set literally touches everything? Whether it's social, whether it's commerce, whether it's human health, whether it's behavior. You can look at any aspect of human endeavor and tie weather to it somehow. The second component is there's data everywhere. A lot of it is free. There's a challenge about commercializing weather data because most people are used to getting data for free or near free. So to try to build a business model around something that people perceive as a public right, it can be challenging, but that doesn't mean it's impossible. And finding the sweet spot between getting something that is at a cost that's appropriate for your target audience as well as something that's going to add value is really where we're spending a lot of our time. So what I'll do today is really just talk about a few things that we're, at a high level, we're doing at IBM. At weather, we map the atmosphere, that's what we do. A lot of the company was started by, the company was founded by meteorologists. Weather is kind of inherent in everything they do. But it's not just weather. So there's a lot that's around geospatial that we're doing. So we'll talk about that a little bit. Really forming the platform that we're providing is, it's a combination of weather and geospatial. So it's really a data-centric platform that can be geared towards anybody from, that B2C user. So anybody with a smartphone is a potential customer, all the way to corporates who are doing, weather and location-based risk management and pricing for some of the largest companies in the world, and everywhere in between. So, your customers literally could be anybody on the face of the earth that has access to technology. I'll talk about, we'll stress about, we know weather, that's what we do, that's the company's business. But again, we really want to emphasize that we are more than weather. And all of this, how does this all come together and what does this mean for this IoT dialogue that has been continually evolving? And I would imagine in the next 5 or 10 years, it's going to evolve even faster. I mean, if you just think about it, if you've been in data science for a while, I mean, this is actually, there's been a lot of talk about, the problems and the challenges, and there's challenges in any field. But man, I mean, it's a really exciting time to be in data science. If you just think about, again, where we are now versus where we were 5 years ago, there's things that we're doing now that we couldn't even have imagined 5 years ago. I mean, the costs to access the data has come down. So if you think about the barriers to entry, costs to access, the cost of hardware, and the availability of talent, all three of these things have really come together, and it's allowed for a lot of entrance into this space. And this is why the startup space here is so exciting. You don't need to, if you're a startup in data science space, your cost is human capital and servers and possibly data. As opposed to more, a traditional business where you have, say you're doing something about technology, you have lab infrastructure, you have fume hoods, you have permits, you have a lot of things that really you need to just get in place before you can even get your idea off the ground. Whereas, in the space we're in, you need a few people, a good idea, and some servers. So what that's done is really allowed this whole groundswell of new entrants into this space. And again, 5 years ago, it wasn't possible. There's a really well-known venture capitalist in the U.S., Steve Jurvetson. He talks a lot about, what are the businesses that are going to be transformational 10 years from now? And he usually throws this out there at a lecture, and he gets answers. But his answer really is, the biggest company that's going to change the world in 10 years doesn't even have a name yet, because so much is going to happen in the next 5 to 10 years that will allow the next game-changing company or technology to develop, that it's silly to even think about who that next company is going to be. And for those of us in kind of this data science and analytics space, I think we can kind of look at it the same way. There's going to be so many things that are going to happen over the course of the next 5 years that we have to have a guide map and we have to kind of think about where we might want to go, but in terms of actually forecasting it, it's going to be an exercise in futility because so many things are going to happen that it'll be considered science fiction right now. So one of the things that we stress is, obviously with a weather company we have a weather bias, but we feel that access to good granular weather data that's personalized do more than, it's a commercial business, so we target ads and we have ads that are triggered by weather and location, and that generates revenue, and that's a revenue stream, and that's fine. But it goes much beyond that. I mean, with the same approach that we're taking towards targeting ads that are weather-driven, that same approach can try to understand contagion effects. It can understand ripple effects in financial markets. It can understand how diseases spread. It can understand how cities function. So there are so many ways that, based on this baseline capability that we're developing, it can touch several of the areas beyond just that weather-location relationship. And again, through some of the things that we're talking about, you start to see how that kind of manifests itself and where we're going in terms of our vision for the future. So, as I said, we map the atmosphere. That's what we do. We process more location weather-based data than any other company in the world. So there's a lot of companies that are weather companies. In the United States alone, I think the last count, there's about 305 individual weather companies, and that's anywhere from a small 2 or 3 person company all the way to companies like the weather company, even larger. But most of them focus on one thing. They focus on trying to build a better forecast. And from a data science perspective, I mean, that's fine. And obviously, the weather company has a very large forecasting division. That's on the B2B side. So I work, obviously, on the consumer side. We're on the B2C side. But the weather company's B2B division is focused primarily on the forecasting piece. So we have a 3-day, 5-day, 10-day forecast. Let's throw all the technology we can at it and try to make that better. And there's obvious value in that. But from our perspective, from the data science side, I'm looking backwards all the time. I want to see where we are today and what can I learn from that data from today, looking backwards, so I can build some kind of a model that has predictive capabilities. So, the one thing that's, we kind of look at ourselves as a differentiator is, instead of trying to spend all of our resources trying to extend the limits of science, and the limits of science right now, you can probably do through differential equations, you can develop a forecast that goes out about 14 days with skill. I mean, and realistically, it's probably less than that. It's probably like 8 to 10 days, 10 to 12 days, not 14, but the limits of science would say 14 days. We're focusing on getting more data at a more granular level, so every single person in this room could have a forecast tailored towards what they do, where they're going to go, how weather influences what they do and kind of guides their lifestyle. And part of that is where do you shop, what purchasing habits do you have, and weather does play a part in all that, and we're trying to quantify that role. How does weather kind of seamlessly influence what you're doing as an individual? So, the forecast is another layer that we'd layer on top of that, so we can kind of understand what you might do next based on the forecast. But the real intellectual property in terms of what we're generating is trying to build a profile based on individual users and aggregate that to build segments to understand what people are going to do, how they move through their day, and where they're going to go as a function of location and weather. So every day we do 26 billion forecasts, and that's growing. So this time last year it was certainly less than that, and 6 months before that it was less. So this is always increasing, and it's going to keep increasing because the more data we have and the more computational resources that we have, and now that we're part of IBM, there was a lot that we could do as the weather company. There was a very well-developed infrastructure and a very well-developed data repository, but having access to IBM's computational resources now, this can scale significantly. So if we're here talking about this a year from now, this 26 billion into the forecast is probably going to be much higher. But nonetheless, it's a very impressive statistic and it's worth throwing out there. But again, getting into the geospatial piece, it's really about connecting that forecast to individuals. So basically everybody, most of the location data we get through mobile phones, both Android and iOS. And the nice thing we have also, being a weather company, 80% of people, so if you have a smartphone, if you have a weather company app download on your phone, 80% of our users actually opt in and give us their location information. So there are privacy issues, and we work really hard against protecting our users' privacy. There's a lot that we do that we don't work with individual user IDs. Everything we do is user ID is stripped away and it's aggregated, so there's no possible way somebody could go and say, this profile is geared towards an individual user. So we go through painstaking means to make sure that those privacy issues are certainly transparent, and we actually go overboard so that nobody could even look at a profile and say, based on, okay, well, this person or this profile, take myself for instance. So we work in Manhattan, so if you looked at a profile where this person comes out of the subway at a certain time, he has an 8-minute walk to his office, 4.5 minutes in between his walk and his subway stop in his office, he stops at a Starbucks. Oh, that's Michael Ferrari. I mean, there's no way that you could look at a profile and say anything about an individual person. But even though that's the case, we still, there's always people that have very significant concerns about privacy, so we do everything we can to make sure that there's nothing that's tagged as an individual user makes its way into our analysis. So everything is aggregated, but the point is everything is connected, and what we're starting to do is by blending, as I said, we have this weather data. There's also companies that have location data, so Foursquare and other companies like Foursquare, they're trying to understand from a location perspective how society works. There's a lot of companies that do that, a lot of companies do weather. There's very few companies that do both. So this is where, as a business model that's based on not one or the other, but a combination of the two, this is where I think we really have a lot of power in understanding, and we could look at it either way. How does location and weather, using location as the cornerstone of the analysis, and then let's layer in weather and see how that drives people, or the flip side, let's look at weather and start, let's take weather as our base level, and then based on that weather, then we'll layer in location and see how one drives the other. It seems like it would be the same thing, but when you actually analyze them, they're two different things, but that's kind of a different exercise. But the point is, we're really doing something unique in terms of actually blending the two. So as I said, I came into data science through physics, so I like to look at things and break it down to first principles. And a lot of data science is becoming extremely complicated just due to the amount of data that's available and the types of data that are being collected and organized so we can start asking questions. But if we want to distill it, let's look at the most basic foundational level. Let's try to understand how these two pervasive factors influence what everybody does, and then start building our business models on top of that. And I feel very strongly that we're moving in the right direction. So again, we've embraced the idea of big data, another term that I don't necessarily use all the time because it's one of those meaningless terms, but again, I think there's been this shift, everybody knows, it's kind of a shift towards smart data versus big data, and I think that's where we're trying to go. It's not necessarily the volume, but what is actually contained in that data. And again, always bringing it back to what is that weather relationship. So even though we're focusing a lot of what we're doing in the geospatial frontier, the foundation still is we are the weather company, and we're using weather as kind of that key driver towards understanding these relationships. So by doing that, we're allowed to, it enables us to just build profiles for users, and they seem superficial sometimes, but when you actually look at the numbers, it starts to paint a picture. So, client names are stripped out of this, but we can start to understand, based on where people live, where they go, their distance from the store, how many times, their signal may have been picked up by a beacon. What is the likelihood that that person is going to go from point A to point B, and then after point B, are they going to go to C, D, or E?